Okay, so we are on, I think it's like 4.3, lesson 4.3. It's been a while, so, but I just call it the vertical line test. I didn't put lesson numbers in this one, but we're talking about the vertical line test in our function chapter. So it says, I can determine whether the relation is a function or not a function because a function is a rule that assigns each input to exactly one output. So if an equation represents a function, there is one and only one value, y value for each distinct x. If any vertical line passes through more than one point on the graph, then for some values of x, there is more than one value of y. Therefore, the relation is not a function. Okay, so that's going to be kind of important for you to kind of understand. And here are the directions. Draw a vertical line to see how many times it hits the graph. If it hits more than one time, it is a function. If it hits one time, it's a function. If it hits more than one time, it is not a function. All right, so let me show you what I'm talking about. First and foremost, let's kind of do some labeling. This is x, your graph, and your coordinate, and this is your y. This is the actual, and maybe I'll highlight these all in blue. This is the actual function here, okay? So let me just keep, here's the function here, here's the function here while I have my highlighter out. Here's the function here, here's the function here, here's the function here, and here, and here, and here. Okay, so those are the functions just so they kind of stick out because it's kind of hard to tell with all those just lines. So what you're going to do is you are actually going to draw a vertical line. So vertical is straight up and line, straight up and down, and you're going to see how many times it hits the graph. So you're going to draw it somewhere where it hits this blue graph. It doesn't matter where you draw your vertical line, you're going to just draw it somewhere. So what if I draw it right here? Boom. And here is where it hits the graph. How many times did it hit that graph that's in blue? It hit it one time. So because it hit it one time, it's said to be a function. Okay, so same thing here. Let's draw a vertical line somewhere straight up and down and see how many times it hits the blue. It hits it once. So that makes it a function. Okay, not too bad. So we can kind of whiz through these pretty easily. So I draw a vertical line. Look what happens here. It hits once, it hits twice. So because it hits twice, this is not a function. So you guys can kind of easily go through and probably drew your vertical lines and be done in probably a minute's time. Okay, so here, hits once, function. This one. Now this one kind of is tricky. I draw a vertical line and it's right on there. Let me kind of go back and draw the blue so you can kind of see that too. So they're kind of both right there at the same time. Well, how many times does it hit it? Well, it hits it here, it hits it here, it hits it here, it hits it here, it hits it. It hits it the whole entire time. So this is not a function. Okay, vertical line, boom, hits it once, function. Okay. Vertical line, hits it once, twice, two times, not a function. Okay, draw a vertical line, hits it once. This is a function. Draw a vertical line, hits it twice, not a function. Okay, so that is part of the vertical line test. So actually drawing a line to determine if it's a function or not. Well, we have to do functions and not functions, but sometimes you guys know we've had graphs, but we also have tables that we have to talk about too. So let me go to the next page. So this is actually going to be page 9, and let's talk about function and not a function, and then you see some tables. All right, I'm going to give you some mathematical language to begin with. So here is a function. Mathematical language, it says x and y, and then x, and then it goes here and here and y. And I know this is kind of different, but I want to keep introducing you to mathematical language. So what this means is if these were points, this might be 7 and -3, okay? If this next one was a point, this might be 3 and then 4. And then this would be a different x, so maybe this is 5, but it goes to the same y. So this would be 4 here, like so. Okay? These are all functions. And what you look at is that the x's must be all different. So I'm gonna pick up my yellow and I'm gonna highlight my x's. Here's an x, here's an x, and here's an x. So when you're dealing with points, if the x's are all different, it's a function. So all of the x's, and I'd write this down, all of the x's are different. And that's all it takes. So the x's must all be different to be a function. Okay. Now, you might be saying, well, Mrs. Smith, what about these y's over here? Like I've got a y that's a 4, and I've got a 4, and then I have a -3. Guess what? We don't even care about the y's. We ignore the y's. So I'm going to pick up a little here. We don't care. This is okay. We don't care about the y's. Don't care about the y's. Okay? All right, so let's talk about not a function. Not a function in mathematical language usually looks something like this. X, and it says y and y. And it would be something like this. So if we put points here, it would be 3 and say this is -2 for the y. And this, because it's the same x going to a different y, it would be 3 and then maybe like 5. If you have these x's that are the same, right here, notice they're both 3's, that's not okay. They're the same. So because they are the same, this is not a function. So if the x's are the same or they repeat, it is not a function. Okay, so of course, you know me, I've got a song. It's to the tune of Conjunction Junction, which used to be a Schoolhouse Rock video back when I was a little kid. I don't even know if you know it, but the tune was Conjunction Junction. Is it a function? Only if the, is it a, I don't even remember. Now I can't, because all I can think about is my song. So here's my song about function. Function, function, is it a function? Only if the x's do not repeat. Function, function, is it a function? Only if the x's do not repeat. Function, function, is it a function? Only if the x's do not repeat. So that's what we do. We check out the x's. So here's the x's. I have a -3, a -2, a -1, a 0, and a 1. Are they all different? Indeed they are. So guess what? This is a function. That's all you have to do. So let's look at the next ones. Here's the x's. I have a -6, a -4, a -2, a 0, a 2, and a 4. Are they all different? Indeed they are. This is a function. Now, what about this? What about this? It's okay. This is okay. We ignore the y's. We don't even care about the y's. We don't even look at them. We just look at the x's. Okay, how about here? Function, function, is it a function? Only if the x's do not repeat. Do you see some repeating going on? Indeed you do. A -3 and a -3 and a -6 and a -6. So this is not a function. Okay, so if you have a table, you got to look at the x's. Last but not least, these are called relations. They're just a bunch of points. And technically, ladies and gentlemen, it's just points. These are points too. They just took them out of the table. But they tried to make you think with these braces and stuff. But if I were to do this, x and y, this would be 2 and 4. This would be 3 and 5. And this would be 7 and 3. Okay, so then I look at my x's. Are they all different? They are. You could just look here. I have a 2, I have a 3, and I have a 7. Are they all different? Yep. So this is a function. You don't have to put them at a table. Once you understand what you're looking for, just look at the x's. 2, 2, and 7. Uh-oh. I have a 2 and a 2. They repeat. So this is not a function. And last but not least, look at your x's. -2, negative what? 0, excuse me. 1, 2. Did they repeat? They did not. So this is a function. Now, before we go on, I want to go back to my graphs. All right, and I want to talk about this now that we know what it takes to be a function. I want to talk about this whole X business repeating. This one was not a function. If I were to put points to this, let's see what would happen. So my line, which wasn't quite the straightest here, but let's say it was 1, 2, 3. So this is 3 and this is 1, 2. This point right here would be 3, 2. And then this point here would be 3 and then -2. Because remember, it hit it twice. Here are my 2 points, here and here. What do you notice about this? Do the x's repeat? Huh. Well, that's interesting. Okay, let's go down to this one. This one was also not a function, and I said it hits it all the way through. Well, what would this be? This is like 1, 2, 3. This is 4. Maybe this is 4, 1. This is 4, 2. This one would have been 4, 3. This would have been 4, -1, 4, -2. I think you get the idea. And look, 4, 4, 4, 4, 4, 4, 4. And notice it's not a function. The x's repeat. All right, one more. If we were to put these in here. So this is like 1 and then 1, 2, 3. So this is 1, 3. This is 1 and then it's 1, 2, -3. So 1, -3. Guess what? Look at, not a function because the x's repeat. So even though we were doing a vertical line test, this whole business of whether the x's repeat works. So function, is it a function? Only if the x's do not repeat. I know, I'm not a singer, but you know what? It helps me remember. All right, talk to you soon.